Good morning, children. So let's do some numericals today. And there is no paper from the board without a numerical from electric current. So numericals here are very, very important. So please don't take this as a choice. So this may come under compulsory question for 2 marks, or it may come as a part of 4-mark question. So children, don't think this as a choice, but rather it's a compulsory question. So listen carefully and also practice how to solve the numericals. So sir, before I proceed to the numerical, just let's revise how the power can be expressed. So power is equal to work done by time, where work done in terms of electrostatic potential is QV. Q is charge, V is the voltage, T time, and we know that Q by T is equal to current. Thus, substituting in the equation of power P is equal to QV by T, you will get IV, or can also be written as I square R, or can also be written as V square by R. Okay, children. So now let's see the problems. Now, what is the question here? A bulb marked 60 watt and 120 volt will offer dash resistance. So how do we solve it? So what is the power? Power is equal to 60 watt and voltage is equal to 120 volts, or rather potential difference is equal to 120 volts. This is how we write. So P and V are given to us, and what is asked is R is equal to how much. So we have to check for the relationship which is having P, V and R in it. Okay, so we have the equation P is equal to what formula you have? P is equal to V square by R. P is equal to V square by R. From here you can write R is equal to V square by P. So thus what is R is equal to V square is 120 into 120 by P. P is 60 watt. 60 2 times 2 into 120 is 240. So therefore the resistance offered is equal to 240, and units are very, very important here. If you don't mention the units at the end, you are going to lose 1 mark. Children, please remember that. So writing unit to the physical quantities, whether it is given quantity or whatever you are determining or finding, finally it is very, very important to mention. So what is the resistance? Resistance is equal to 240 ohms. So it's a direct substitution, very simple problem. Right, so please take a screenshot. So the next one is the practical unit of electrical energy. So in your textbook it is given as power. See, it is not the unit of power. Usually whatever the electrical department people, they'll come and take out the unit wise consumption and give us the electric bill. There it will be written in kilowatt hours. Kilowatt hour, even though you feel like it is in kilowatts, you feel like it to be power. It is not power, it is energy. Right? It is electrical energy consumed by us. Usually in practical units, we'll be talking it in terms of kilowatt hours. Okay, let us convert this and see that how many kilowatt hours is equal to how many joules. Okay, so now let us see 1 kilowatt hour. Kilo in the sense it is 1000, you know very well, that is 10 cube. So write down 1000 here. Watt in the sense power, unit of power. Unit of power is energy by time, where unit of energy is joule, time unit is second. So 1000 into joule per second, right, into hours. Hours can be written into 60 into 60 seconds, is it not? So 60 minutes, each minute comprise of 60 seconds, therefore 60 into 60 seconds. Now the seconds and seconds will get cancelled. So now here 1000 and here 2 tens, thus 36 into. So this can be written as 36 into. How many zeros are there? 5. 10 power 5 joules. So now can you see that this is like a unit of energy? It's not unit of power. Children, please keep that in mind. It is unit of energy, electrical energy, practical unit of electrical energy. And this is 1 kilowatt hour is equal to 36 into 10 to the power of 5 joules. Very important relationship to be remembered. Okay, children. So this is about kilowatt hour. Right. So take a screenshot and copy this one. And based on this, now we are going to see a numerical. Let's move on to the numerical. So it sounds to be a little bit lengthy, but it's easy if you understand. So a house has 3 tube lights, 2 fans, and a television. Each tube light draws 40 watts. So let's write the information one by one, right? So first write about tube lights. So for tube lights, how many tube lights you have? 3 tube lights. And each tube light draws how much? 40 watts. And for how many hours does it? So 40 watts. The fan draws 80 watts. TV. On the average, all the tube lights are kept on for 5 hours. So into 5 hours. How many days it is like? Find the cost of electric energy used in 30 days. So this is all together consumption, hourly consumption of electrical energy in case of tube lights. So what do we have here? 3 tube lights for how many watts? This is 40 watts. Number of tube lights, and then this is hours, and this is days. So therefore this is have like hourly wise consumption you have. So you'll be getting the answer in joules, is it not? Right. So watt means joule per second. Hours means 60 into 60 per second, is it not? So therefore now we are going to convert this into kilowatt hours. We have it in watt hours. We have it in watt hours. So now let me do first multiplication part, then you will understand. So now what is it? 3 3s are 9, 9 5s are 45. So 45 multiplied by 40. So 4 5s are 20, 4 4s are 16. It is 180. 180. So how many? So 1 0 here, 1 0. We left these two. So it is 18,000 watt hours. We got it in watt hours, is it not? So watt hours. That means in a day 5 hours. In total days how many hours? So that is 18,000, which is equal to 18 in place of 1000. This is kilowatt hours. So how many units of consumption is done because of tube lights? 18 kilowatt hour monthly. Okay, so then next one. What is the other case given? For fans. So now see how many fans? Number of fans 2. So how much energy or how much power it is drawing? The fans draw 80 watt power. So it is in watts. It is number again. Into like how many hours? 2 fans for 12 hours, right? 12 hours. It is in hours into 30 days again, because this is for 30 days. So now upon simplification you will get 2 6 are, 2 3s are 6, 6 12s are 72, 72 into 8. 2 8s are 16, 7 8s are 56, 57, 5 7 6. Now this is 1 0 and this is 1 0. So 2 zeros. So now what do we have? 57,600 watt hours. We got it to be in watt hours. Why am I converting into kilowatt hours? See, because he gave the cost at the end per kilowatt hour. Cost at the end is per kilowatt hour. So it's a must for me to convert. So now divided by 1000. So it will be 57.6 kilowatt hour. 57.6 kilowatt hour. Right. Now what is the other thing that is given? Tube lights is done. Fans is done. And then television. Right. When it comes to TV's consumption. So TV, what is it? Only one TV is there. and the TV draws 60 watt. So 1 into 60 into how many hours TV will be on? The two fans for TV for 5 hours. TV for 5 hours into 30 days. So now let us see. So 6 5s are 30, 33s are 90. How many zeros? 2 zeros. So this is watt hours divided by 1000. So that is 9 kilowatt hours. So children, now we got consumption in kilowatt hours for each electrical device. So for tube lights, you got it to be 18 kilowatt hour. For fans, we got it to be 57.6 kilowatt hours. TV, 9 kilowatt hours. What should we do now? Before we go for finding the amount, we have to add all the consumptions, right? Right. Therefore, total consumption. Therefore, total consumption is equal to, so 18 plus 57.6 plus 9 kilowatt hours. So that is equal to, so 9, so 0.6 as it is, 9 plus 7, 16, 16 plus 8, 24. So 2 comes here, 7 plus 1, 8. So 84.6 kilowatt hours. So now we have to find out what is the cost that we have to pay to the electrical department at a rate of rupees 3 per kilowatt hour. So therefore total cost is equal to 84.6 into 3. So that is 3 6 are 18, 3 4 are 12, that becomes 13, 3 8 are 24, 25. So 253.8 or 253 rupees 80 paisa. So this is the cost. This is the cost, rupees 253.8, or finally you can write it as rupees 253 and 80 paisa. So this is how you can write down the total bill. Okay, so let's see the problem once again. So I'll read out the problem. A house has 3 tube lights, 2 fans and a television. So 3 electrical devices are given. Each tube light draws 40 watts, fan draws 80 watts and TV draws 60 watts. So this is the power consumption by each electrical device. On the average, all the 2 tube lights are kept on for 5 hours. So every day for 5 hours on an average. On an average means maybe one day you may keep the tube lights on for 8 hours and for one day 3 hours or something like that, but you are finding on an average as 5 hours. 2 fans for 12 hours and TV for 5 hours, right, every day. So find cost of electric energy used in 30 days at the rate of rupees 3 per kilowatt hour. So now when you have, right, when you multiply the number of devices with the power drawn with the hours per day and number of days, you will be getting the value in watt hours. Then afterwards divide it by 1000, then you will get it in kilowatt hours. Okay children, so this is how you have to solve. So sounds to be lengthy problem, but very very easy. You have to multiply category wise, you have to take, and you have to multiply with number of pieces with the power consumed, and then a number of hours in all 30 days. Okay children, so we have determined for tube lights we got it to be 18 kilowatt hour, fans 57.6 kilowatt hour, TV 9 kilowatt hour. Then after finding individually, we added all that for total consumption. After the total consumption is done, we multiplied with the cost and we got it to be rupees 253 and 80 paisa to be the total cost for the electrical energy we consumed. Okay, so take a screenshot. And this is a problem from your textbook only, from your exercise. It is problem number 3. And then this is the solution part. Now let's see the effective resistance in case of number of resistors connected. So let's see the problem by problem. The first one, if you observe these two are in series. So when you solve, it is a must for you to understand how the connection is. So end to end connection. That means this, the end of one resistor is connected to the end of the next resistor, and that is waiting. It is open for something else. It is not getting connected to this again. If this is getting, that means two common ends. So this is one common end, and if one more common end is going to be there between these two, then that will become a parallel connection, but it is end to end connection. So therefore this is in series. So first one, series. So what is effective resistance in series? Rs is equal to R1 plus R2. R1 plus R2, which is equal to 2 plus 3, which is equal to 5 ohms. So this is the solution for the first one. When you solve it, you have to draw the diagram and mention R1 is equal to 2 ohms. Let R2 is equal to 3 ohms, and effective resistance in series as Rs. Write all the steps and then solve. Okay. Right. Now move on to the second one. So now here observe this carefully. You have one. So it seems to be end-to-end connection, but see, this is coming and getting connected to this one. So therefore two common ends are there for this. Right? So if we redraw this, this comes around like this. This is a 4 ohm resistor, and this is connected again like this. Is it not? This is connected again like this. So this is important. You need to visualize it. So it is parallel connection. So one across the other one. That means two common ends are there here. So two are connected in parallel. So what is the effective resistance in case of parallel? 1 by Rp is equal to 1 by R1 plus 1 by R2. Or on taking the LCM, you will get it as 1 by Rp is equal to R1 plus R2 by R1 R2, or Rp is equal to R1 R2 divided by R1 plus R2. Now substituting this, R1 R2, 4 into 2 by 4 plus 2, 8 by 6. So that is 2 4s are and 2 3s are. So hence what is the effective resistance in parallel? 4 by 3 ohms. So this is the effective resistance in case of second problem. So take a screenshot of that. Visualization is very important. It seems to be as though it is in series, but it is not so. Now the third one. So when you look at the third one, right. So how is it? Two resistors are in series. Very good. And there is one resistor which is in parallel to these both. Is it not? Both. It is commonly connected across these two resistors. So what we have to do is, first you have to find out the effective resistance of these two. How are these two? In series. Right? So therefore, solution for the third one. So first find out the RS value. What is RS value? R1 plus R2. Suppose if you write it as, so that is 2 plus 2, which is equal to 4 ohms. So you got RS to be 4 ohms, right? So now redraw the circuit. So it is something like 4 ohms is here and 2 ohms is now in parallel to this. So that means this is redrawn like this after determining the RS value. Okay, right. So now this is something like two resistors are in parallel. So when two resistors are in parallel, Rp is equal to R1 R2 divided by R1 plus R2. Is it not? Just now we have seen. Right. So now here R1 R2, that means 2 into 4, 8 divided by 2 plus 4, 6. So that is 4 by 3 ohms. So here Rp is equal to 4 by 3 ohms. So what's the difference between these two problems? If you observe this one, we have this only getting parallelly connected to this directly. And if you observe this, you have two resistors in series and one resistor is connected across, that is parallelly, for both the resistors, Now just for idea's sake, let me give you one problem as here as a homework. So you have to solve it. Okay. Right. First take the screenshot of this. So first the problems. See the fourth problem also. Please, I'll read it out for you. A wire of resistance R bent into a square, and our job is to find resistance across diagonals. Okay, keep this in mind. Now we are going to solve this. A wire of resistance R is bent into a square. Resistance across diagonals is dash. This is the question. So these are the questions. Right, now the solutions. Take the screenshot so that we can move on to the next. Yes, this is your homework. So what is the homework? Here two resistors are connected. They seem to be series, and one resistor 4 ohms is parallel to 2 ohms. So what is that? So here if you observe, first these two are in parallel, isn't it? The effective of this is in series with this. So this is how you have to. So what you have to solve is first this parallel condition. Apply the parallel condition to this, and then find out effective resistance of parallel, that is Rp. Then that Rp should be added to this in order to find out the resistance between points A and B. Is that clear, children? So please, whenever such problems are given, you have to see what to determine first. Okay, so now this you have to determine first. In the previous case, you have determined series of these two because this is in commonly connected to both. So first you have to find out the series and then parallel there. But here it is the case like this. Okay, first you have to find out the parallel and then you have to add it to this one. Okay, children. So please take a screenshot of this, solve this problem and post me. So now solving the fourth problem. What is fourth problem? It is something like a wire is given to you whose resistance is R. Okay, and this wire is bent into a square. Okay, let us bend the wire like this. I am bending it here and again it here and again it here, becoming a square. Square means all four sides are equal. So now this is how this is bent. Now this wire is of same thickness, is it not, when it is bent also? But the length is bent in such a manner that it is L by 4, L by 4, L by 4 and L by 4, is it not? So, and you know that resistance directly is proportional to L. So, when length is reduced by 4 times without changing any other dimensions or other measurements, obviously resistance becomes R by 4. So, this is R by 4, this is R by 4, this is R by 4, this is also R by 4. Now, if I redraw this as a circuit, this comes out to be like this. The resistance offered in this part of the wire, resistance offered in this part of the wire, resistance offered in this part of the wire, and then resistance offered in this part of the wire. So this is how I have redrawn. So this will be R by 4 because in the problem no value is given. He said only the resistance to be R for the complete wire, and the wire is bent at like to become 4 equal parts. So R by 4, R by 4, R by 4, R by 4. Now what is the question asked? What is the question asked? Question is not asked to find out between these two. It is between the diagonals. That means like this. Question is asked to find out like A and B. Suppose if you ask between A and B. That means now see, observe, these two are in series, end-to-end connection. These two are in series. Very good, is it not? Now, effective resistance of this and effective resistance of this are in parallel to each other. See, a cross connection parallel to this. So, suppose if I redraw this, so now series connection R by 4 plus R by 4. So, what is that? 2 times of R by 4 is R by 2. So, I can redraw this like this. See. Right, and then this is another resistor. So R by 2, R by 2. So this converts like this. This is A and this is B. Can you see that these two are parallel? Yes, beautiful. So electric current diagram problems are very interesting to solve. But thing is, you need to identify how the connections are made. Okay, children. So now the effective resistance RS. First let us find out RS. which is r by 4 plus r by 4, which is equal to r by 2. Right? So rs across one branch, rs across the second branch is also the same, r by 4 plus r by 4, which is equal to r by 2. Now the effective rp is equal to rs1 into rs2 by rs1 plus rs2, is it not? So you have 2. That is, what is rp formula? r1 r2 divided by r1 plus r2. So I took this as rs1, that is series branch 1, series branch 2. So thus this is the thing. So now substituting these values here. So you have rp is equal to rs1 is r by 2 into r by 2 divided by r by 2 plus r by 2 is r. Half plus half is 1 full. So therefore now r by 2 into r by 2 is r square by 4 into r. So 1 r will get cancelled. This is r by 4. So therefore resistance across or resistance across diagonals is equal to r by 4 ohms. Okay children, so again look at the problem again. A wire is given for us of resistance r. It is bent into a square such that lengths of the sides are becoming L by 4, L by 4, L by 4. Since no other changes are there and r is directly proportional to L, resistance will be r by 4, r by 4, r by 4 across the sides. Now the question is asked to find out across the diagonal the effective resistance. The circuit looks like this. So you have one branch with two series resistors, another branch with two series resistors. On redrawing it will become like this. So first each branch series effective resistance is r by 2. This is what we have determined already. And then finally we are finding the RP value. Okay children, take a screenshot. Very, very important problem. Sometimes it could be asked as a triangle also. Take a screenshot and then copy it. So with this I'll close today's class.